When you replace a crankshaft or camshaft position sensor, but your engine still won't start, the problem is usually not the new sensor itself. These critical sensors monitor engine RPM, timing, fuel injection, and valve timing. The most common cause of no-start conditions after sensor replacement is installation errors. Studies show that 78% of these issues are preventable with correct procedures. First, verify the sensor air gap. Magnetic sensors typically require a gap between 0.020 and 0.050 inches. Too close and the sensor can be damaged by contact. Too far and the signal will be too weak. Next, check all wiring connections. Examine the connector for damage, verify proper wire routing to avoid electromagnetic interference, and ensure all ground connections are secure. Always follow manufacturer torque specifications when mounting the sensor. Over-tightening can crack the sensor housing, while under-tightening can cause vibration and signal issues. Sensor quality matters significantly. Aftermarket sensors can have high failure rates due to incorrect specifications. For critical applications, use OEM or OEM equivalent sensors to avoid compatibility issues. Modern diagnostic tools with AI-enhanced capabilities can help interpret sensor data patterns and identify issues quickly. These tools provide real-time monitoring and can detect problems that traditional methods might miss. Remember, most post-replacement no-start issues stem from installation errors, not faulty sensors. Focus on proper air gap, secure connections, correct torque, and quality components for successful repairs. After verifying the physical installation of your crank or camshaft sensor, the most critical step is performing the ECM relearn procedure. This process allows the engine control module to establish new baseline parameters for the replacement sensor. Modern diagnostic scan tools are essential for this process. These tools allow you to clear existing diagnostic codes and monitor live sensor data during the relearn procedure. Many vehicles require a specific idle relearn procedure. This typically involves allowing the engine to idle for a predetermined time while the ECM learns the new sensor's characteristics. Some vehicles may require a specific drive cycle instead. If problems persist after the relearn procedure, advanced diagnostics using an oscilloscope become necessary. The oscilloscope can analyze the sensor's signal pattern to identify issues like damaged reluctor rings or missing teeth. Reference voltage verification is another critical diagnostic step. Most sensors operate on either 5-volt or 12-volt reference circuits. Using a voltage reference simulator can help isolate whether the issue is with the sensor or the ECM's reference circuit. Here's a critical statistic. Skipping the ECM relearn procedure can increase sensor-related issues by 300%. This makes the relearn procedure not just recommended, but absolutely essential for successful sensor replacement. Finally, staying current with evolving sensor technologies is crucial. Continuous education and manufacturer-specific training programs help technicians adapt to new diagnostic procedures and emerging sensor technologies in modern vehicles.